The following video shows our latest product, E+, to address the problem of ambulance delay in the city of Virginia Beach by predicting potential emergency calls. In the past few years, more than 10% of emergency calls in Virginia Beach were delayed, increasing the death rates of people in emergency, while on the other hand, the ambulance drivers spend too much time to a distant destination. The key problem behind this is the uneven allocation of ambulance resources, so our objective is to optimize the allocation and save more lives. An ambulance driver might want to know when and where there will be a potential emergency call and wait around the risky place to reduce their response time. Our product E+ serves as the best companion for them. Our app could provide recommendations of high-risk level areas to hang out and show the surrounding information to better locate the ambulance, such as hospital and pass calls. When there is an emergency calls coming, we will link the app to the EMS system to get the driver to their destinations. Okay, here is how our E+ works. Imagine I am the ambulance driver. When I enter this app, here is my location and surrounding information. Now the first thing is I want to know where should I go. So I click this and see the risks map of Virginia Beach. I can also filter risky places to make it more clearly by clicking on this button. If I want to see where should I go tonight, I can switch time period to see the risk map in the future so that I can better arrange my time. Alright, now I see 3 recommendations on my destination. These are decided by 4 indicators: the risk level, average response time, arrival time, and current number of ambulances in that area. I can also see the average risk level and response time across the city. Under this is a risk level prediction during the day, and I can also switch it to the week and month. If I have decided to go to this place, I press go, and then I can see the route leading me to that place. After arriving at this risky area, I can get the information of risk level and current and past emergency calls around me. If I want to know more about this area, I can look at the location of past emergency calls. I may want to stay around the place with high density of past calls. I can also see the location and detailed information of a hospital, such as commute time. What's more, I can also check if there are other ambulances around me and avoid being too close to it. Our app is also linked to the EMS system. If I get a task from the sender, the task screen will pop out with the location and the route for me to the nearest event, and then to the nearest hospital. I can confirm the task and check the detailed information, their location, the priority, number of beds, and what kind of aids are needed. I can also make a phone call to contact the patient. Okay, now we have seen all the functions of the app, and most of the functions are based on our data and model. So now I want to briefly introduce our data and model behind this app. Our goal is to predict the number of calls per 3 hours by location. We use the dataset from City of Virginia Beach Open Data and so on. Our variables include 4 categories: location, time, spatial data, and demographic data. Among these 4 groups, time is the most important predictors. We want to use time variables to capture the trend and the pattern underlying the emergency calls. Here is our model building process. We employ the Poisson regression and try different models. We use the first 3 weeks in August as our training set and the last week in August as our test set. We also use different test sets to validate our model across time. We then compare our models and choose the one with the smallest prediction error. The significant variables in our final model are shown here. We could see that the emergency call in the past played a very important role in our prediction. Okay, here are the outcomes of our final model. The graph on the left shows our prediction in 1 week. The blue lines are the predictions and the orange lines are the actual calls. We could see that the model performs well in most days. On the right is a map of average prediction error across the city. The mean absolute error is about 0.16, which means our average prediction is about 0.16 higher or lower than the actual calls. Our model is also better than the kernel density in predicting areas with high risk level as shown in the graph. Alright, at the end of our presentation, we want to share some future thoughts about our app. First, we can use data and model to help the health department to allocate the ambulance more efficiently. Second, we are now using 3 weeks data as our training set. If we are using more data to build our model, the results may be much more better. Finally, we can use machine learning algorithm to improve our results. Okay, this is our presentation, and if you want to know more about our app, please go to this website at the bottom or email us. Thank you.